In this video, we'll be finding the limit graphically of a piecewise defined function. Our problem is let f of x equal x squared minus 4 for all x's that are not equal to 1, and then f of x equal 2 when x is equal to 1. And we're asked to find the limit of f of x as x approaches 1. Now if we look at the graph of this, we see that for all values except x equal 1, our graph is going to be the parabola x squared minus 4. Now the graph of this one intersects the x-axis at plus or minus 2, and then it intersects the y-axis, if we put 0 in here for x, at negative 4. So we have a parabola that goes through these points. And then for x equal 1, we have a hole in the parabola. So our graph looks something like this with a hole right here. And then when x is equal to 1, y is equal to 2. So this point fills in that hole. Not literally, but for x equal 1, y equal 2. Okay. So our question is, what is the limit of our function as x approaches 1? So what we have to ask ourselves is, as we approach x equal 1 from the left, y approaches what number? So as we stay on the graph, so coming in from the left, we're approaching what value? So the x is approaching 1, the y value is approaching negative 3. Then as we approach x equal 1 from the right, y approaches what value? So approaching from the right, we're coming in from the right, but we have to stay on our graph. So we're approaching the same point here, right here. So our y value is still negative 3 when we approach from the right. So then we can say that the limit of this function as x approaches 1 is negative 3. Now if you wanted to look at this on the graphing calculator, we need to be able to graph a piecewise defined function. And the way you do that is we're first going to take this expression and multiply it by this expression. And we need to put parentheses around it. So we have open parentheses x squared minus 4, close parentheses, open parentheses, x. And then to get the is not equal to, we need to go to the test button, which is second math. So if we do second math, you can see that is not equal to is choice number 2, and it's not equal to 1. And then we're going to add to that this expression multiplied by this one. So in parentheses 2, and then times, and then we need x equal 1. And then second math to get our equals. Now what this is doing, let me just explain this a little bit. The calculator will test to see if this expression is true or not. If it is true, the calculator gives a value of 1. So you're taking this expression, x squared minus 4 times 1. If the expression is not true, then the calculator gives back a value of 0. And so you're not graphing that because it's 0 times that quantity. So if we look at the graph, now I don't think that the dot shows up. No, this dot won't show up. Let me do a zoom decimal, which is zoom 4. And yeah, there it is. Okay, when you do a zoom decimal, that value, when x equal 1, does show up, but otherwise it doesn't. So it's important to remember that the limit is what the graph approaches. It's not this point right here. The graph approaches -3 from both sides as x approaches 1.